Hello, everybody. So this is going to be the video for Lab 9. So let's go ahead and open the lab up. And this is the lab that is supposed to help you learn what loops are, since that was the subject of Chapter 9, Week 9. So let's go ahead and get right into it. So I'll open Eclipse here, and I will actually, let's go back to the lab. Let's see what we're doing. So it says we'll go over most of these questions. Okay, well, not on lecture on Monday because this is the lab video, which is not on Monday, but we'll go over these. So it says you have to answer these questions and submit a PDF file. Okay. Now you can write this in any kind of word processor that you want. Um, so if you have access to Microsoft Office, you can use Microsoft Office through like Office 365, for example. If you don't want to, you can use like Google Docs. That would be fine. So I'll just open a blank document here. Um, all right. So let's go back to the assignment, which is in the tab next to it. So the reason you're turning it in as a PDF instead of Java files is just because instead of a whole problem, you're just doing little kind of snippets of code here. So let's go ahead and look at them. So problem one, it says write a for loop that prints the numbers 0, 4, 8, 12, 16. Okay, so I will put this into Eclipse because we need to try it out to make sure it works. So let's make a Java project. Let's just call it Lab 9. Us open up Lab 9 and create a new class. Let's just call that Lab 9. Let's put the public static void main. And here we go. So let's go ahead and put our generic for loop here. And so the thing about a for loop to remember is that you have this three sections here. And the first section is what we call the initialization, and then a semicolon. And then you had what we called the condition, and then a semicolon. And then you had what we called the iteration, and then no semicolon. And the point about that is that initialization happens one time before the loop starts. Condition is checked, and the loop only executes if it's true. It's checked every time. I didn't type that, but it's checked every time. And the iteration happens at the end of each iteration. So if we go back to our assignment here, and it says we want a for loop that's going to print the numbers 0 up to 100, right? 0, 4, 8, 12, 16, 100. So um, the way you would do that is your initialization happens once. So you normally would set that to the first number you want to see. So if we're counting from 0 to 100, set it to 0. So we'll start at 0. Then we're trying to get to 100. So our condition should be while x is less than or equal to 100, because we want all the numbers from 0 up to 100. So less than or equal to 100 is a good condition. And then the iteration here, normally we see something like this, like I plus plus. Um, and then system.out.println, we can just print the I. The I is going to be changing every time through the loop. So I is going to start at 0, it'll print 0, then I will be 1, it'll print 1, etc. Now, if you're paying attention, you'll realize, let me delete this code that doesn't work. If you were paying attention, you'll realize that this is not going to do what we want, because you can see that this prints out every number from 0 to 100. And we only wanted the numbers 0 through 100 counting by fours. And so what do we have to change? Well, to make this count by fours, this is the part that needs to change, right? I plus plus means add 1. I equals I plus 4. That means add 4. Or alternately, you could write that as I plus equals 4. And then it'll count up by fours. So it starts at 0, goes up to 100. So you need to get used to writing for loops like this that will count up what you want to count up. So that's the first part. So it says to write a for loop that'll print the numbers, and we need to put this code into our PDF. So you go to any kind of editor here. Whoa, just let me type, guys. Just put your name in there. You can do a date. I'm not picky about how you type this or anything. So it's I don't know, to say 1026 or something. Let's say lab 9. Oops. It's kind of not the best looking way to type it. I guess what I'll do is right click here and I'll see if I can paste this um, without formatting. It won't let me. Crazy. I think I can do it. I'm on a Mac, so I have to, there's a secret keys you can hit. You can hit Shift, Option, Command, V to paste without formatting. Um, try to get that in there. In terms of the font, you want it to try to look decent. If it looks really ugly, then you might want to change the font. If you're looking for a font to change it to a monospaced font. Um, Console is a monospace font. Courier is a monospace font. Some other fonts that have the letters mono or MS. Like so, this is well, actually, that trebuchet might mean the MS might mean Microsoft, but it might be monospace. And anything that says mono is monospace. So like mono roboto, for example. Um, Weird. Roboto mono normal. You don't have to change the font. It's just it'll look more like a programming assignment if you do. What's next? So we go here. Recall the remainder operator can check if a number is divisible by another number. And then this is just an example. It's not what you're doing, but just to show you, if I just comment this out, we don't need to see all these numbers anymore. Um, so like if I put a number here like 13, uh, run. What? What? Oh, I'm gonna put divisible by 7. So like if I put a 13 here and we run this, we get nothing. If I put a 14 here and I run this, it says divisible by 7. If I put like 22 here, I get nothing again. If I put 21 here, I get divisible by 7. So the point is that this modulo operator, right, modulo 7 here, when you take a number and you do modulo 7 and it equals 0, that means that that the remainder was 0 when you did the division 21 divided by 7. So 21 divided by 7 uh, is 3 with a remainder of 0. We compare the 0 to the 0, and that's what means it's divisible by 7, getting a remainder of 0. So with that said, we just want to remember that. And then we want to look at a for loop here. We'll copy all the code. We will paste it. And it says, write a for loop that will loop from 1 to 100 in stuff. So our for loop um, needs to go from 1 to 100. And we should be getting better at this because we can do, now, is it Up to 100? Yeah, up to 100. So we'll do less than equal 100, just like we did for the last one. And then we can do I plus plus. So that'll be my loop that goes from 1 to 100. Now, the difference between this one and the last one, first of all, we're counting by ones, not by fours. But also, it says we want to print out the numbers that are divisible by 3 or 5. And it's a not a complicated condition, but it is a condition. So up here is an example of checking if a number is divisible by 7, for example. So if you do this basic thing here with something like I modulo, let's say 3 equals 0, and then we print out I, and that's all inside of our for loop, which is going from 1 to 100, then what's it complaining about? Oh, there's an extra parentheses here. Um, so I is going from 1 to 100, and then we're going to check if I is divisible by 3, and if it is, we print it out, and you'll see that we're getting all the numbers that are divisible by 3. And of course, if you change this 3 to a 5, you can see we get all of the numbers divisible by 5. Now, it says specifically here that we want all the numbers that are divisible by 3 or 5. And so what you have to do there is just change this condition from being not just divisible by 5, but 3 or 5. And so you have to take this entire condition, put an or, and then make sure you do the same thing but with a 3. So now if I is divisible by 5 or I is divisible by 3, then we print it. And we're doing this for all the numbers between 1 and 100. And so you look at it and you see we did 3, 5. So 3 is divisible by 3, 5 is divisible by 5, 6 is divisible by 3, 9 is divisible by 3, 10 is divisible by 5, and so on, all the way up to 100. All the numbers divisible by 3 or 5. Um, this is a really common problem in a beginning programming class. If you go to Project Euler, let's go archives, projecteuler.net, you'll see that problem 1 is multiples of 3 or 5. So it says we list all the natural numbers below 10 that are multiples of 3 or 5. We get 3, 5, 6, 9. The sum is 23, and it says find the sum of all the multiples of 3 to 5 below 1,000. Well, we didn't do exactly this problem, but we did something related, right? We found the multiples of 3 and 5. Uh, okay, well, anyway, we did that. That was the second problem. So we'll just copy this, take it over to Google Docs, paste it in there. I will never be able to make those line up because I hate text editors. Yeah, that's just going to be completely impossible. All right, well, whatever. Not too picky, I guess. So we got it in. Next one. Next one. Number 3, it says explain in words what this code will do. And if you don't know what it does, it'll be easy to run it. So this is you can see it's a public static void main. I can just take this entire thing and we can replace our entire main with it. Now be careful, right? Like if you put the cursor next to public static void main here, you can see that this curly brace ends up with this curly brace. So if I'm replacing the entire thing, I need to delete everything except this class, and the curly brace starts and ends there. And then paste that in. So we get the curly braces, right? So when we run this, let's see what it does. Double my num 17. Let's run it. Okay, so this is what it did. And we could look at them and we can see that the numbers, we see 17, 8 and a half, 4 and a quarter, 2 and an eighth. 1 and I guess that's 1/16. Not that we need to know. But you can see that these numbers are getting smaller and smaller and smaller, right? And they get smaller and smaller and smaller. And then the last one is 1.01 times, and remember the E means times 10 to the, that's scientific notation. So this is 1.01 times 10 to the negative 6. Um, so what happened? So this number started out at 17. And then while the number was greater than 1 times 10 to the negative 6, notice that this is still a little bit bigger. This is 1.01 times 10 to the negative 6. This is 1 times 10 to the negative 6. So this is a little bit bigger. So while the number is a little bit bigger or bigger than 1 times 10 to the negative 6, we're printing it out, which is what we see here. And then my num equals my num divided by 2. So we're dividing the number by 2. And you can see that, right? Because like 17 divided by 2 is 8.5. 8.5 divided by 2 is 4 1/4. 4 1/4 divided by 2 is 2 1/8. I mean, as a decimal, 2.125. Divided by 2 is 1.0625, and so on, right? We're dividing by 2 every time. So what is this doing? Well, we're starting out with 17. We're repeatedly dividing it by 2. And when the number becomes small enough, specifically smaller than this, then the loop stops. So we should say that. So we can go here and we say that, let's see, uh, this sets a variable to 17, then repeatedly divides divides it by 2 in a while loop till the condition, what was it called? MyNum? Yeah, MyNum, greater than 1 e negative 6 becomes false. Becomes false. Variable MyNum. 17. Then it repeatedly divides it by 2 in a while loop until the condition MyNum greater than 1 e negative 6 becomes false. Uh, then the loop stops. The end. That's all. That's what it does. Um, okay. Why doesn't it like it wants to divide, then repeatedly divide it by 2? No. Um, it is wrong. That grammar is wrong. All right. So anyway, that's all we're doing is this. Um, and then to turn it in, regardless of whether you're using Microsoft Office or in this case, Google Docs, we need to get a PDF out of here. So maybe I will change the name of it to like Lab 9. And then file, I would do download, and I would download a PDF is what I would do. And this PDF is what I would need to submit here. And so we expect a file upload, and it should be a PDF. All right. So that's it. That is Lab 9. So that's it. I will talk to you guys later in the next video, which will be Lab 9B.